Welcome to the NGSS Assessment Academy Part 5. In this episode, we're going to talk about tracking NGSS learning gaps. Before we get into all of the content, I do want to introduce myself. So my name is Brendan Finch. I was a high school and middle school science teacher in Los Angeles. I taught for LAUSD for 4 years, for KIPP, for Green Dot, and for a virtual school called Kava. InOrbit is a rigorous NGSS assessment platform. We now have assessments for grades 5 through 12. We're offering free pilots. We'd love to help you out, and hopefully you can collect some data on learning gaps during distance learning, hybrid learning, or in-person learning. We have hundreds of phenomena on the site, so even if you're just looking for phenomena, please go check it out with thousands of assessment items now. We also pre-made diagnostics, formatives, and summatives that we built. They're all for grades 5 through 12. It's amazing. We find eye-catching phenomena and ask students to make sense of it. We also write custom NGSS assessments. Today, we're going to talk about tracking NGSS learning gaps. I'm going to start out getting specific with elements. We're going to go deeper with diagnostics, DCIs, and SEPs. We'll talk about formatives using 2 dimensions, sense making and summatives, and then maybe you'll even let us track your learning gaps for you, because a lot of this is really complex and these standards are multidimensional. We would love to help you make that a little bit simpler for you. Let's get specific with elements. We're going to pull apart the elements, and I want to explain why we're going to pull apart these elements. The complexities of the performance expectations and the student journey are focal points in all of this. We want to identify everything that's required in the current grade level. And these are complex standards. They're literally multidimensional, and we're going to break them down into discrete elements so that we can start to assess and show progress towards that. And therefore, the lack of progress showing learning gaps within, where we want students to go in their journey. And we'll also look at the prior grade level band to serve as a starting point for tracking data on what students need to access the current content. They, stand on the platform of their last science instruction in cells or physical science or chemical reactions, what have you, and they need that in order to access everything else. So as a middle school teacher, I taught a lot of students that didn't get any science instruction in elementary school. I also taught high school physics, and I had a lot of students that really didn't, understand a lot of the basic concepts and conceptual concepts. So getting into the math was tough. So we want to identify what students should have known in middle school or in elementary school, and then assess after that. The end goal is, after we pull everything apart, that we'll pull them back together to build some diagnostic, formative, and summative assessments. We have actual examples of all those to show you and walk you through. So I hope this is super specific and targeted and gives you a real thing that you can chew on and create your own versions of. First, we'll get specific with elements, and Mr. or Mrs. Puggy down here is gonna, take a step by step. So we'll start with the elements of a performance expectation, and we're gonna chunk these assessments. We'll make several small formative assessments for one specific element. The goal is, even within a PE, and the elements within the DCI are super complex. And there are many different things students need to do in order to meet and fulfill that DCI, and then also meet the performance expectation. And then we're going to also scaffold up from those things. So what should they know from the last grade level band? And then what steps do they need to take to get to the current grade level band? The way to think about tracking this, if you're not using InOrbit, is to build a spreadsheet. And each one of your assessments should be focused on a really discrete skill and a really discrete part of an element. And I'll talk about that in just a second. So for MSPS 1-2, this is what we're going to work on all throughout this webinar. We're going to analyze and interpret data on the properties of substances before and after the substances interact to determine if a chemical reaction has occurred. There are a lot of different elements within this. We're going to drill down to just a couple specific elements and pick them apart. So before we get to that middle school performance expectation, PS1A is also covered in 5th grade. And within the 5th grade performance expectation, PS1-3, PS1A is the DCI, and students are asked to measure properties to identify materials. So measurements of a variety of properties are used to identify materials. This is the first time that properties is really introduced to students. And we don't get too much into the quantitative elements of this. It's more qualitative at this point. And from that 5th grade level, we're going to go up into the middle school level, where students are now looking at characteristic physical and chemical properties that can be used to identify materials, going far beyond just properties and getting into now the differentiation between physical and chemical properties and the the fact that there are pure substances that have characteristic properties, and that we can use those to identify materials. So we're just going to talk about that one DCI progression here. So for PS1A, we're going to start at the prior grade level band and move up. So what we've done is we've just teased apart this 5th grade element and then all the steps needed to get up to the middle school level. So at first, students need to, measurements, they need to know that measurements and observations can show properties. That's the distilled version of this. So what's a property and how can we measure properties? Each of these could serve as discrete elements that students are assessed on to track their progress towards the middle school level. And then once we get to the middle school level and we know that students don't have learning gaps going from the 5th grade up to that middle school level, we can then use our formatives and our summatives to really track, all right, now can we pull pieces together, and then can we do all of it with some sense making for a summative assessment. So what's a property? How can we measure properties is the first step. And then can properties change? That's another really discrete element within that progress up to that middle school level. And then examples of chemical versus physical properties. So we want to differentiate between those things. We want to give students examples of chemical properties, examples of physical properties, maybe have them identify those things. And now, can you identify the substance or property? So we can give them a substance, a phenomena, and have them try to identify it based on the information that we give them. And that will finally get us up to, chemical and physical properties can be used to identify substances. So each of these can be one discrete element. You can have do nows or exit slips. I'm a huge fan of exit slips and small formative assessments that can be used to assess student progress as you move through. For SEPs in middle school, we want to look at the elements in that performance expectation and then also go back to what students should have done in 3-5. So in middle school, for analyzing and interpreting data, we want students to analyze and interpret data to determine similarities and differences in findings. Analyze and interpret, so it's pretty complex. At the 3rd, 5th grade level, we want students to compare and contrast data collected by different groups in order to discuss similarities and differences. So comparing and contrasting is way lower level than analyzing and interpreting. So analyzing and interpreting means we're finding some meaning within that data, and comparing and contrasting is really just calling out that there are differences. So we'll start at the prior grade level band again, and then we're going to move up from there. So in 3-5, we're going to compare and contrast to find similarities and differences. What's similar, what's different, just identification of those things. That's where students can start. We can have questions that ask them to identify similarities and differences. And then later on, we can get into, does this statement correctly identify differences? So now students can analyze a statement, a claim, some evidence to decide if that does identify differences. Now, can they identify the reasons why the data is different? Now we want to get into meaning and get into much more deeply, do you understand reasons why? Aaron and I, or Grenard and Aaron and I, are all doing the same experiment and we get different data. Why does that happen? Moving forward from there, we want to ask students, is there enough data to support this claim about differences? So now doing some analysis of what's going on. Is there data to support claims? And then also, what conclusions can you draw from the data? Once they've gone through and they've shown that they understand that there are reasons why data is different, is there enough data to support a claim? And then what conclusions can be drawn? So now they're making their own claims. They're, they're interpreting data, they're analyzing it, they're finding similarities and differences, and they're searching for meaning within that data, which is kind of the crux of the difference between the 3-5 level and then what students do in middle school. On Inner Orbit, we track all of these discrete elements and we aggregate them over time. We have so much data for you. Let's talk about diagnostics with DCIs and SEPs. Before we get into formative assessments, we want to understand what students should have learned in the beginning, and that's why we picked apart all those elements within those DCIs and SEPs, the progress that students should have gone through. That's where the diagnostics really come in. We'll look at the elements of prior performance expectations. For DCIs, these are going to be simple questions, asking students to identify correct answers or explain a process. They're going to be, think 10 years ago assessments. And for SEPs, we're going to ask them to represent things with their SEPs, not to make sense of things, but to represent. Can you represent this process? Which piece of evidence supports this claim? You don't need to write a CER statement, but just identify things and represent them. SEPs don't have to be content specific. So we have an SEP diagnostic assessment that asks students to analyze statements about passwords and having a solid password on your phone or computer or email account. And students have a bunch of opinions about this, and we ask them to identify what are facts, what are beliefs, is there enough evidence to support this claim that this student makes, and pick them apart. So for SEPs, I'd also recommend you can, get creative with it and find assessments that aren't related to content and just allow students to show that they can, differentiate between these different things. They can draw a model of how air goes in and out of the lungs, lots of different things that they're processes they're familiar with and concepts they're familiar with that aren't related to science content. And that can allow you to sort of differentiate, do you understand how to model or how to identify evidence or what evidence is? And then we can also evaluate, can you then apply that skill to this content? For 5th grade, in PS1A, we want students to measure, a variety of properties to identify materials. So our diagnostic question is going to get at properties of materials. So which characteristic of this onion is not observable with your eyes? So why does cutting onions make us cry is one of our phenomena, and we have much more complex questions. But at the very beginning, we want them to identify characteristics. We want them to identify traits, parts of the onion that's not observable. So if they can identify those things, then they're well equipped to go into the more complex questioning later on. At the middle school level, we then want them to say, their characteristic physical and chemical properties. So we need to ask questions about characteristics, so physical properties and chemical properties. So we have another question. This is an example of a diagnostic question for them at the middle school level. And I'd recommend using that 5th grade question first, and then the middle school level question. So is this a physical or chemical reaction? Do students understand that there is a difference between physical reactions and chemical reactions? And in a combustion, what's happening here? Is it physical or chemical? Real simple question. This is like a quick little do now warm up question. For formatives, we're going to start now blending 2 dimensions together. We're going to layer on the complexity. We're going to bring it all in. So we'll pull elements together, see if students can go further with each of those pieces that we covered in our diagnostic questions. The multiple elements will have higher complexity. Maybe we'll ask them to make sense of a phenomena. Maybe there'll be some SEPs in there where they're drawing a model of something, they're writing a claim, or picking evidence that supports a claim. The first one that we're going to look at covers, so MSPS 1-2, and we're just looking at the DCI and the SEP, so analyzing, interpreting data, and structures and properties of matter. So we have a big question here with this prompt, and it's, is there evidence of a chemical reaction? There's a GIF of iron wool burning, and mass is clearly changing over time. It is becoming more massive over time as it burns. And then below that, there's an image or a GIF of a cup of water evaporating over the course of several days. And it's a time lapse of that evaporation. And so this formative assessment asks, so one of your classmates makes the following claim. These are both the same since parts of water and iron are turning into a gas. The iron wool burning is not a chemical reaction because some of the iron is turning into a gas. So they think it's a state change. And students have to say the statement is true or false because the change in water is blank and the change in iron is blank. So now we want to get a little bit deeper. We have an opinion or a claim that a student makes, and they have to decide if it's true or false, and if these are chemical or physical changes, and to drag and drop each of those in there. So it's much more complex than that initial question of what is this a chemical or physical change? Now we want them to analyze what somebody else, a statement somebody said, and identify each of those things as physical or chemical changes. We'll get to another formative question that's going to involve PS1A and patterns. So we'll use the DCI and the cross-cutting concept together. Surface tension. So this is an image of water droplets going down on a penny and forming this, like really, really cool looking bubble. And this is all about surface tension. This is it. We have an entire set of questions around this, but one of the questions is draw a model in the space below to explain how water's microscopic properties would lead to the behavior we observe in this GIF. So students are modeling, and this is involving an SEP, but it's not the SEP in the performance expectation. And they're also using structure and properties of matter to describe that there are, properties that things have at microscopic levels, and that the pattern, so macroscopic patterns, seeing the water behave like this, is related to microscopic or atomic level structure. So something is happening at the microscopic level that leads us to see the water forming this, sort of skin. Students draw a model of this. This gives you an idea of how well they can incorporate patterns and how well they can incorporate their knowledge of, physical and chemical properties of water. Following up after a formative is probably the most essential element of all of this. Review it, do think alouds, correct misunderstandings. A formative assessment that you do not review later on is not a formative assessment. You are just giving a quiz. Formative assessments are meant to inform your instruction. You should be adjusting the learning experiences that students are going through. I strongly recommend, and we've heard lots of people talk about, think alouds as you go through a phenomena. After students go through it, explain why would you draw a model. So first, what's happening with that water? What's going on here? And why is that unique or interesting? What's the phenomena? Do a think aloud, explain what you would think as a teacher, and then go deeper and show students how you would then model, and show different examples of student models to show how they represented what's going on between that. You should have new learning experiences once you figure out that students are struggling with something, and then moving forward, you want to reassess what's going on. The reassessing can use the same questions, and it can also use questions that are different. We have multiple phenomena for every performance expectation. So ideally, you can give some questions for one formative and some questions for another formative, all within the same performance expectation. Let's talk about sense making with summatives. Once students have gone through your diagnostics and they've gone through your formative assessments, we want to get them to really investigate what's going on and fully assess a performance expectation. They should make sense of phenomena, and they should pull together the DCI, the SEP, and the cross-cutting concept. And you should have already identified gaps and had prior learning experiences that you put in there, new learning experiences to help address the gaps that you noticed. Then you get to the really, really cool stuff. This is my favorite part about the NGSS, is where students actually act as scientists now, and they're making sense of things. They are doing the work that they would do as scientists. For MSPS 1-2, we need to incorporate analyzing, interpreting data, structure and properties of matter, also chemical reactions, and then patterns in order to make the full assessment here. I'm going to give you two different examples of assessments. The first one is there evidence of a chemical reaction? In the phenomena here, there's an image of a iron wool burning. It's clearly becoming more massive over time. We call that out in the comments. And then below that, there's an image of a glass of water over the course of several days that is becoming less massive. It's clearly losing water over the course of a few days. So we want students to write a claim supported by evidence and reasoning that answers the following question: is the change we observe in the iron wool a chemical reaction? Now, students have to describe what patterns they're seeing. They need to use their knowledge of chemical reactions and structures and properties of matter. And they also have to analyze and interpret data. So there is data here. There are graphical displays and textual displays of data. And they need to analyze that, interpret it, and come out with some kind of conclusion. We also have the same CER question about the water that's changing over time. So can you write a CER statement to answer this question? Is the change in water a chemical reaction? And students need to explain that that is or is not a chemical reaction. They should be able to show that there are patterns in microscopic properties that lead to macroscopic behavior. Same thing for the iron wool burning. Ideally, you're now collecting this data and you're tracking it graphically in a way that's easy for you to see and analyze over time. Orbit has awesome reports on this. We track chemical reactions over the course of multiple assessments. We're looking at the significance, the number of questions, and the alignment of those questions to the standards, and how these different bands of students perform over time. This is an actual screenshot of our longitudinal reports from a real teacher's account outside of LA. So if you've been using Orbit, or if you're using what we showed you with, at least pedagogically, how those diagnostics, formatives, and summatives look, then you can have columns for each of those things, track how well students performed on those, color code it, make some conditional formatting based on that on a spreadsheet, and track that. Or you can just use all of our awesome reports and then track all of these discrete elements of data automatically and have all the questions thoughtfully written around that. We also have a feature where you can upload your own assessments into Orbit, then tag them with the same degree of detail and elements of the standards, so that if you're in New Jersey or Connecticut or California or Washington, you can have really relevant phenomena that students are looking at. In California, it's been all about fires because California. And so we have lots of phenomena on that here, but y'all are in different ecosystems and students experience different things. So you should have phenomena around that, but you can upload those to our site if you want, tag them as standards, and get the same level of detail reports over the course of the school year. Awesome. Never read assessments again. So we have a ton of these. We have custom assessments that we'll write for you. We'll give you PD like this to walk you through it. If you're interested, sign up for a free pilot and let's chat. And also, if you're watching this on YouTube later, we'll have a link to meet with us and chat with us there. Please join us next time where we pull it all together in Assessment Academy Part 6, where we talk about backwards planning from summative NGSS assessment, because you're all building units based on the NGSS and having these separate little chunks of assessments. And what we talked about today does give you some cohesive plan, but I'd like to start from the end and work towards the beginning next time. So we're going to send the invite out soon to everyone that registered for this. And if you're curious about, learning more in the future, please sign up for that or find a time on our calendar and we'd love to chat with you. If you have questions, email me, brendan@innerorbit.com. And if you'd like to see our content updates and get some of our phenomena, all that cool stuff, then follow us, InnerOrbitEDU on Twitter, and we'd love to hear from you. And if you want to meet to chat about our purposeful assessments, about backwards planning, about a cohesive assessment plan, send me standards you'd like to assess, and we'll try to create an assessment for you, brendan@innerorbit.com, or you can tweet at us or go on our website and find a time on our calendar, and we'd love to chat with you. I'm so grateful for your time. Thank you very much for hanging out with us. Have a beautiful day, and thank you for everything you do.